Hello friends, you have a paper that looks like this. It's a review of all the things we've been learning over the last few weeks, which has been kind of weird because there was a long break in between, but you've been doing good, so let's just keep going. This is an overview, so it's just linear systems of equations, and it's all the different ways we could see them. So if you look at your paper, each box is a different representation, so we have equations, we have tables, you'll see graphs, and you could also see situations, so like word problems, right? So those are the four different representations of showing two different lines. We can use these representations to write equations. And then we can use those equations to find the solutions. And a solution would just be like an x and a y value, so like a point. So like for example, here is a point, whatever that x, y is, that's the solution. This is just a quick review of like how many solutions do you see. So this one has one. And then how would we describe these two? We'll just do one example from each of the representations. So I'm going to slide down. You have to excuse me, I've got kind of a weird setup with my camera here. All right, it doesn't matter which one we start with. Basically, these are very similar. It's kind of like those y equals equations we were just doing. You could take, let's just do the one on the right. So negative 4x plus 4y equals 20. Off to the side here, we're just going to rewrite that. And the problem is right now we can't graph that because this is in standard form and we need it to be y by itself in order to graph, right? So just like we were doing, we're going to try to get y by itself. Add 4x, add 4x. Bring the 4y down. I got 4x. And a positive 20. From there, I'm just going to divide by 4, divide by 4, divide by 4. So these should be ones that you're actually pretty good at. 4 divided by 4 is just 1x. So I could just write x, and then 20 divided by 4 is 5. So I have one equation in the y equals form. You would want to do the same to this equation to get y by itself. And then once you have those two, you're just going to graph. Your final answer should be something that looks like that, right? And that's where you're actually going to take your graphing calculator and you're going to type in, so I don't know if this will actually work. Let me see here. I'll just zoom in. Whoa! So basically to find like a line, right, I could just type in an equation, 3x plus 2. I could type in another equation like x plus 5, like the one we just did. I could graph it. And I'm just looking to see where the lines cross. So you have fancy calculators where these are actually like colored, so like one line's blue and one's red. If I do second calculate, so that calculate button right there, and I want to calculate the intersection. So it says, which is the first line? For me, it's just that bottom one. Enter, enter. So really it's just calculate, enter, enter, enter. And it says that the intersection is 1.5, 6.5 for these random equations that I just entered in. That won't be your answer for this problem because we haven't solved for y yet. So your job on this is to solve for y, and then plug in those two equations, find the solution. So this, I feel like y'all are good at, right? This was the one that I think might kind of throw you for a loop, even though it's like kind of an old idea. So let me zoom out again. Boop. Okay, so if I were to look at, let's just say this one here, right? So I have two tables and I need an equation in y equals form. So one thing you could do is you could actually just say, okay, I need 2 points, so I'll cross all the others out, and I'll just solve for the slope, right? So 175 minus 75 is 100. 1 minus 0 is 1. So my slope is 100 over 1. And then that would attach to the x. And then my y-intercept is actually in the table, right? Because it's whatever is y when x is 0. So my y-intercept, I'm starting with 75. So that's 75 positive, right? So just from getting the slope, I can actually start with my m, and then I could just, in this table, because I have a 0, I can figure out what the y-intercept is. So that one's done. This one, though, let's just try a different way. So if you remember when we were doing tables, and actually Samantha would be a good person to talk to about this one, because she did this in Miss Hess's class. But remember how we did like statistics and we put tables in and then we figured out what's the relationship? You can actually do that with any table. So I can go to stat, I can edit, and then I can recreate the table, right? And then I can go 100, 400, 500, 900, and 1,000, right? So I would do that just to make sure you know how to do this on the calculator. So if you want to pause the video, you can stop. But then at this point, right, you're just going to go stat, calculate, right? So calculate, and then linear regression is the one that tells us how to make a line. If I hit calculate, right, so you'll notice like it's telling us ax plus b, but that a is really just the m. So y equals 100x plus 100, right? So that's my a, and then that's my b. So if we were trying to find the solution, right, is there anything you notice about these two equations, right? Like I could put them in the calculator and see what happens. So I could do clear, clear. So the first one is just 100x plus 75. And then the second one is 100x plus 100, right? And if I graph, so I just had a line shoot way up and another line shoot way up, right? If you see how they're kind of close together, you could actually zoom in. Whoa. Okay. So those lines are going up pretty quick. If you notice in this picture, they're not actually touching, but if I were to do like let's do calculate intersection, first curve, second curve, if I guess, okay, it's saying that there's an error. So when I'm trying to find the intersection, the calculator is saying, no, you can't do that. Well, if you look at this problem, why can't we do that? The slope is the same, so they're just parallel, which means there's no solution, right? And you could just put no solution because the slope is the same. So you may want to play with both ways of doing it, or you just pick the easier one. To do your one example, on the back, let's do this. So if you were to pick, let's say, the graph on the right, probably the easiest way to do it, because they're giving us points, right, is just to take 2 points and make a table. So x and y. So I have 219 for this light gray line. And then if I follow the line up, I have a 6 and a 37. And I could actually do the same thing I just did and go back and do stat, edit. I can clear these lists, right? And I could find a table just using those 2 points, or like make a table using the 2 points and then go do stat and calculate the linear regression. So that would be a really simple way to do it. For those of you who feel comfortable finding slope off a table, right, you could easily subtract, but that's not going to give you the y-intercept. It's just going to give you the slope if I did the rise and the run, right? So I think the easiest thing at this point is just to take this, make a table, and then do your y equals something x plus whatever the b is. So that's what I would do for this line, and then you could do the same for this line. And if that works for you, then I wouldn't even count and do the rise and run over here. I mean, you could. But if you notice, like, the graph's a little weird because there's a -2, and then there's a bunch of spaces and a 0. So you'd actually have to go back and add in the missing numbers and kind of skip count. So again, I might just use 2 points from a line, make a table, and then do the same thing for the line that's going down. Once you have your 2 lines in your equations, then it's easy to find a solution. That's just a calculate and then enter, enter, enter on the intersection. All right, so with all that said, let's just do one of these word problems. With these, I kind of feel like, yeah, let's just read. We'll do this one. It's kind of the same idea as this one. So it says, at a sale on winter clothing, Cody bought 2 pairs of gloves and 4 hats for $43. Tori bought 2 pairs of gloves and 2 hats for $30. So right away we know we're talking about 2 pairs of gloves, 4 hats, and then there's 43, right? And the next sentence, it's very similar. 2 pairs of gloves and 2 hats for a different price. It says find the prices of the hats and the gloves. So in Algebra 1, anytime you see a situation like this, it's talking about X and Y, they're just not going to say it like they did in 8th grade. Instead, you have to be able to identify what's changing. So whatever is changing, that's going to be your variables. So I'm just going to pick an X and a Y. In Algebra 1, 2, it's always going to be just 2 things. So we have an X and a Y. We don't have any more variables than that. And so in this problem, we're talking about the prices for gloves and the prices for hats. So I'm just going to write in order gloves and hats. And just to make sure that I don't mess up, if X is my gloves, anytime I see the word gloves, I'm going to write an X. 2 pairs of gloves. Hats, I'm going to say Y, hats, Y. And what that does is it helps me see where the numbers attach. So 2 pairs of gloves. So 2 goes with the X, 4 goes with the Y, and together that makes 43. So the other thing you want to look for in problems is, are you given a total, right? And so that 43 is the total price for 2 pairs of gloves and 4 pairs of hats. So our first equation would just be 2 gloves plus 4 times the price of the hats makes 43, right? And then we'll just kind of box this off to the side. Our second equation would just be Tori bought 2 pairs of gloves and 2 hats. So 2 times the number of gloves, or the price of gloves, 2x, 2 times the price of the hats makes $30, right? So if you wanted to get a solution, right, and answer the question, so hats and gloves, right, so hats and gloves, you would just need to solve for Y, yes. So this is just more solving for Y. So I think if you can get these set up, you can set this one up, just solve for Y and get your solutions. We're at 14 minutes, so I just want to cap it, give you some time to work. Figure out what you can, come to the next class with questions, and good luck.